In this example, I'm going to discuss formatting output. So I have a short main program. You can see I have some double variables declared with initial values. X is 4.44, Y 5.555, Z is 6, an integer A, which is assigned the value of 10, and then I have output statements just displaying all of them. And when I run this program, you can see kind of how the defaults work in that you'll see the double values, X 4.44, 5.555, and Z, which is 6. This is how the default they display by default. The exact number of positions that are required to store the value is what you will see. If you have a value, and I can even change, remember this is a double, so it's going to get stored as 6.0, but I can just put 6.0, but over here you'll see it's only 6. So by default, if there's zeros after the decimal place, you don't see the decimal point and you don't see any trailing zeros. So these are how your values, your integers and doubles will display if you don't have any format manipulators in there. So what we're going to do next is talk about formatting the output. And the first thing you need to know is that you need to include a library called iomanip. So in order to do this, you will have to have that library in there. And the first thing I'm going to do is I'm going to talk about setprecision. And what setprecision does is it sets the number of places after the decimal point. And setprecision works in conjunction with another format manipulator called fixed. So if you want to change all these values to, let's say, have 2 places after the decimal point, you can come in, and sometimes I just, if they're all going to be the same, I'll tend to do it like right before all the cout statements. I'll put fixed first and then set precision, and I'm going to set the precision to 2, and that means everything from this point of the program on will have 2 places after the decimal point. So now I'm going to run it, and now you'll see what my values look like. 4.44, 5.55, 6.0. And let me just do this to show you. Run this. Because you'll see if it's 6.66, it is going to round this value up, so you can see that over here. That rounding does take place. Now, it doesn't round the value of y, it just rounds it when it displays it. So technically in memory, y still has 5.666, but this is just when it displays it. Now notice, a is an integer, so nothing happens to a. All right, so that's kind of why I have that in there to demonstrate that. So you don't have to put this in front of every line. You just want to put like fixed, set precision. A lot of times you have everything formatted the same, so I tend to do it right at the beginning of all the cout statements. But let's say I wanted to change my precision. So let's say I want it to be 2 for X, but I want to change it to 1 for every Y and below. So I can run it here, and you'll see once I change the set precision, everything from that point in the program now has 1 place after the decimal point. So you only need to do this once unless you're changing it back and forth, and that's fine to do. Like let's say I wanted to change it back to 2. For Z, so I can do that. But once fixed is there, you don't have to keep repeating the fixed. But if you take fixed out, it's not going to work. So it's important that you put fixed in before you try to use set precision. And again, make sure that you're aware, it has no effect on integers. This is only the case for doubles. And as I said, you need to include this library once we start to use our format manipulators, in this case fixed and setprecision. Sometimes you might see a program that has another manipulator in it called Showpoint. Newer compilers really don't require you to use Showpoint. So Showpoint used to have to be in there to force the decimal point to appear in values that had zeros after the decimal point, but now just using fixed and setprecision will do that. So Showpoint's rather optional. You don't have to use it, but if you ever see it in an example, that's what it's there for.